Get the...
Hello, and welcome back to Deanie Teaches. Today we're going to cover the concept of time with regards to introductory physics. Now, in normal everyday life, we use time to create an order of events. Hopefully you agree with that, but I'll give you an example just in case. Let's look at the order of events of my day today. At 8 o'clock a.m., I woke up. That's event number 1. Then at 8:30 a.m., I went back to sleep. I would call that event number 2. Now, event number 3, let's say it happens at 4 o'clock p.m., I woke up again. That's event number 3. What we have here is a sequence of events with specific times of the day. Now that's how we use time in normal everyday life. But what about physics? In physics, we want to know 2 things mostly. Number 1 is the order of events, exactly like we use time in everyday life. But number 2, we want to know the duration of the event, right? Essentially, the duration is how long something took to happen. Now, how can we decide how long things take to happen? What units do we use? Well, in order to measure how long something took to happen, we need a time standard. And the time standard you're probably most familiar with is the second. However, a time standard can be found with any repeatable event. For example, one event could be the rotation of the Earth. Now, if you know basic astronomy, you should hopefully know that the Earth rotates a lot. In fact, you could call it repeatable. And because of that, we can use it as a time standard. So, the duration of this time standard would be one rotation of the Earth, aka 1 day. And one rotation, or 1 day, is approximately 24 hours, which is also 9 times 10 to the 4th seconds, approximately. What I've just given you is an example of a time standard. The 24 hours, the 9 times 10 to the 4th seconds, the 1 day are all time standards. And we know we can use it as a time standard because it's repeatable. But you might know that the rotation of the Earth is not always constant. The rotation changes slightly over the year, and so 24 hours is just a very good average that we use on Earth as humans for everyday things. For a true time standard, we need something repeatable and absolutely consistent. And to do that, a great invention called the atomic clock was invented. Here's a diagram of an atomic clock that uses cesium, and I got this picture from the National Research Council of Canada. So like I said, time standards must be repeatable and consistent. What makes the atomic clock repeatable and consistent? Well, essentially, an atomic clock is a timekeeping device whose intervals are set by the vibrations of an atomic system. So, atomic clocks use vibrations of atomic systems as time intervals. These vibrations are extremely consistent. They don't really change. And we usually use a system of cesium atoms to get our time standards. Specifically, in the 1967 13th General Convention on Weights and Measures, the time standard was decided to be 1 second. But what is the second defined as in terms of our atomic clock? Well, 1 second is defined as 9,162,631,770 oscillations of the light emitted by a cesium-137 atom. So, a cesium-137 atom emits oscillations of light about 9 billion times, and that time period is what we define as 1 second. This was a very introductory look into time, which is going to be used in a million bajillion calculations coming up. So, I hope you enjoyed. Like and subscribe, and I'll see you next time. Happy learning.